Okay. All right. So for those of you who don't know me, hello. Thank you very much for inviting me and for attending. We're going to be talking about VRF, which are basically the large scale building versions of heat pumps. Okay. So we're going to, you know, about our firm, we're a consulting firm. My group is Passive House. We do large scale passive house. Prudence just told you. So what we're going to go through today is very, very quickly, in 15 minutes, we're going to talk just some basic definitions of VRF, not all heat pumps and everything. I'm assuming you understand how a heat pump works. Major system components, the pros and cons of these systems, design considerations for comfort, operations considerations, what we're seeing in the field right now, what we still don't know, and what we're going to be doing moving forward. And I just want to do a preemptive strike. If anybody here is from a VRF company, this is not a downer on VRF. This is just lessons learned and sort of here's a heads up if you're using these systems. And I want to tell you, if you're using them in your first year, just take a deep breath. You have to commission your building for the first year, like any other building system, but it's just more eye-opening in Passive House, right? It's like just at the forefront. Oh my God, why is it not working like it's supposed to work? So variable refrigerant flow is what VRF stands for. They're generally modular. They're outdoor units, approximately 6 to 12 ton size. That's the scale we're talking about. And one outdoor unit can be attached to many indoor units of many types. And you have the expansion valve, which does the extraction or input of the heat into the space in the indoor unit, the terminal unit, what we call. And you can have floor mounted, you can have concealed ducted units with short duct runs, you can have just a ceiling mounted unit, and you can have a wall mounted unit. There's all kinds of options for these, and they all have their pros and cons. Our focus today is just on how these things operate and my general recommendations from what I've seen so far. And if you are in the industry, or if you have more experience than I do in this, please shout it out at the end. So air source, heat pumps. Heat pumps, I just want to make this clear, are not a renewable energy technology. Geothermal is not a renewable technology. It is a system that takes heat from one place and transfers it to another place, okay? So an air source heat pump, like the VRFs that we're talking about for these large scale projects, take heat from the outdoor air and move it to the indoor air, or they push heat to the outdoor air after they take it from the indoor air, right? A heat pump can move it in both directions. So I just want you to understand that. You're going to hear the terms water source in other areas where a heat pump takes heat and transfers it to from a water source and moves it around the building. Ground source takes it from the ground and moves it to the rest of the building. And then there's inverter driven, which is a variable speed compressor. We're talking about variable refrigerant flow technology right now. So the main considerations when you're looking at these systems are, do they have the capacity that you need? Can they supply the heating you need in really cold climates, right? So we have what's called cold climate heat pumps, cold climate VRF systems. You want to make sure you're looking for that in cold climates. Capacity, actually how small can we go? Because we all know our passive house projects are, you know, super low heating loads. What's the smallest units we can get for the terminal units inside the project? And then can we get enough out of that same unit for cooling, right? So in our projects that we see in the Northeast of the United States, we're seeing like let's say 1 ton of heating would equate to probably 4 tons of cooling, because our projects are cooling dominated. So that's the kind of ratio you're looking at. It can even be even worse than that. So can you get the efficiency you need when it gets cold, right? And then how much heating cooling do you have and how much energy does it cost? So there's always that cost balance. We're changing, we're getting a very efficient system according to the market research, or excuse me, the manufacturer's specifications, but how much does it cost, right? Okay, so here's some just high level pros and cons. I just tried to throw some out there. There's much more to it than this. So the pros, we're gonna go down the pro side first. Heat recovery is it, and I'm gonna show you what that looks like, is setting up the system in a way where if I'm really cold in my apartment, I can run heating, but if my neighbors or somebody on the same floor is on the south side and they need cooling, they can run cooling at the same time, okay? So you need a heat recovery system to be able to achieve that. If you don't have that ability, you're basically what they call heat pump mode, where you're either in heating or you're either in cooling if you're all on the same, at that same condenser. You can have fewer pieces of outdoor equipment with these systems because, like I said, one condenser can handle multiple terminal units on a floor. So you go up to 15, 20 units depending on the manufacturer. It's an all electric solution. We're all striving for all electric. There's a cold climate solution. There's multiple manufacturers that provide cold climate solutions for VRF, for heat pumps. And then they really do have high efficiency ratings if you look at the testing reports. Now, if we go to the con side, when you go to that heat recovery mode where somebody can do heating and somebody can do cooling at the same time, you actually have an extra refrigerant loop in the building, which means you have more refrigerant in the building. You actually have higher costs for materials and installation. The smallest units we can still get are somewhere around 4,500 BTUs. On the heating side, that's still too big. We could use something that's somewhere between 1,000 and 2,000 BTUs on heating, but then again, for cooling, we need, probably at least double or triple that. If you're trying to bill your tenants for heating or cooling or both, you actually have to have a third-party person process that information so that you can parse it out by apartment, because you've got one condenser handling 10, 15, 20 apartments, right? So you need somebody to handle that billing for you. And then if you do not have heat recovery, overheating is a common result of a heat pump system. And I'm going to get into that a little bit more. So again, this is heat recovery system. We have 3 refrigerant loops running through the building. That extra loop is so that you can share the refrigerant and exchange heat from one apartment to the other. That's what makes it work, the simultaneous heating and cooling. That's what makes it more comfortable. Is it market rate or affordable? If it's market rate, you're probably going to put more money into the building. If it's affordable, you got to be more careful of your budget. Are you obligated to provide cooling? Yes or no? If you are obligated, then you probably want to go with a heat recovery system. If you are not obligated, a heat pump system might be right for you. And you can just say to people, if it's warm in here, open your windows, right? That's not in your contract. Who's paying for cooling? Is it the owner? Is it the occupant? That also is a question of whether or not you should put this in. And then the cost differential, I've heard quotes from 15% extra for heat recovery to 40%. I think it's closer to the 15% end that I heard. 40% was more years ago than the 15%. So I think people are starting to get used to it a little bit. So design considerations, sizing is really important. I'm sorry, I'm trying to get rid of the pictures over here on the side so I can see this, my screen. Page back up. So it's not possible for small passive house spaces with respect to heat load. You can't properly size this wall mounted head is going to come at a minimum of 4,500 to 6,000 BTUs. The load in a multifamily apartment is probably 500, right? So you're like 10 times oversized. And then you want to change the settings so that the fan shuts off when it's not calling for heat. They come from the factory as a fan continuous mode. So even if it's not calling for heat, the fan's going to run on low. You definitely want to make sure that the settings in the unit are set so that your fan is not calling for heat when the heat is not needed. Stratification of temperatures. If you're using a wall-mounted unit with a VRF system that's up high, you're going to have stratification, right? The temperatures are warmer at the ceiling than at the floor. So higher return temperatures lead to lower efficiencies. Also, if you're in a heating dominant setting, say you have a historic building that's more heating dominated, or you have a single family home that's more heating dominated and you're using a wall mounted unit in a mini split system, you want to maybe go lower, use a floor mounted system that it'll increase the efficiency. Most of our large scale projects, our dense projects in North America will be cooling dominated. So these high wall mounted ones are okay, but you have to consider in an apartment, a 1, 2, 3 bedroom apartment, you're going to need one of these in each area that has an exterior wall. So you're going to be drastically oversized. Okay, so if you can, you don't want to do a unit in every room. Zoning. If you're going into heat mode without heat recovery and you're either going to be in heating or cooling and not the option to do both, you want to make sure you zone these floors properly. So you can see this is, if you look at this, we are facing this wall here is facing southwest, this is facing southeast. South is this way. So You want to make sure you zone your apartments together. You also want to make sure you put spaces with the same heat loads and temperature profiles on the same zone. This is a case where this is a historic retrofit. The stairwells and hallways could not be insulated according to historic retrofit, but the bedrooms are super insulated. So these, if we had them all at the same temperature setting, would be calling for much more heat than the bedrooms, or excuse me, than the apartments. So they're driving the refrigerant flow in the lines. And as long as you have refrigerant flow, you have this heat bleed that's going into all of the spaces on the same zone, because it's like a refrigerant loop. You can't have anybody just completely cut off. The condenser wouldn't run properly. So even if this stairwell was set at 70, like the apartment, it would run more often. And if this apartment didn't need heat, it would still get heat. And so you're going to wind up with overheating. These are infrared images of the units at the house at Cornell Tech, right? So this is a heat pump only system. This is one apartment that had a wall mounted unit and a floor. Most of them had floor mounted units. Neither of these rooms are calling for heat right now. And yet you can see the refrigerant charge in the line is making the unit put out about 92, 93 degree temperature. So obviously the building is warmer than 68 degrees set point, right? All of that heat is just loading up into the spaces. And then finally, you really want to make sure you're protected against snow and ice. You don't want these condensing units. This is just a little mini split system showing, but it can show the impact of snow and ice on these units. So you have to make sure you're prepared. So design consideration summary: if cooling is desired or being provided, seriously consider heat recovery. Limit the number of terminal units in each apartment, not necessarily per space, but in each apartment. Consider population in the space. Is it affordable multifamily where you're going to have really high density and a lot of internal gains? Is it market rate where you're going to have less internal gains? Are you going to have seniors that really want a warm apartment, right? Like all of these things come into play. And then zone for orientation, space loads, and set points. Make sure that all three of those things come into play when you're doing this. Operations consideration. So as I said before, most of our multifamily buildings will be cooling dominated. They usually have set times when they don't have heat recovery that they change over from cooling to heating, and then in the spring from heating to cooling. It depends on what you're obligated to do for cooling, but you may want to extend that cooling window. So if you normally turn over from heating to cooling October 1st, you may want to consider November 15th. These three thermostats are from 3 different VRF projects in heat pump mode, and they are showing you that the set point on the thermostat is way lower than what this one's off, and this, they're way lower. And this one here was 30 degrees outside, this one was 40 degrees outside, and I think this one was about 50 degrees outside. That was just recently. So these people wanted a cool apartment, but they can't get a cool apartment even with their windows open. So really keep that in mind when you're doing this. Dealing with passive house windows in multifamily buildings have limited opening profiles. So even if you say, well, it's very valid to open your window, and cool off your home, it is. But if you only have a 2-inch or 4-inch opening and an awning, you're not getting a lot of cooling from that outdoor air, no matter how cold it is outside. So you have to keep that in consideration. Dealing with airtight envelopes, we just don't lose heat to the outdoor elements as we do, so the internal gains dominate. Commissioning, please keep this in mind. Commissioning is an ongoing task for the first year or two. It is for all buildings really, but our passive house buildings are being so strictly reviewed that, and we're expecting them to work better than they are. Just keep it in the back of your mind. Commissioning takes a year or two. Our engineers are good, are really the ones, and we're using repeat engineers. Each building is different, and each building's occupants are different. And then we're missing the point where we're educating. We're turning over the building and we're not getting to the O&M staff and the residents. And that's a really critical link. We have to get to the people who are going to take over the building. I was talking to the building manager of this building, and he had no clue that he should expect an overheating problem. And I said, I understand. That is a big failing of where we are right now. And our team is really trying to rectify that. So some of the things we don't know still are the actual operating efficiency or COP of these systems are, I don't know, I've heard that the manufacturers have these great monitoring systems and, you know, can do all this analysis. I haven't seen one in any of our projects. And we need to try and figure out what it is for each manufacturer, what it is they own, what it is we need to see, and make sure in design that we're going to get that, because we don't have enough data points in the system to be able to evaluate. They supposedly can get it for us, but we just can't get it because it hasn't been ordered up front. How do we get owners to install this monitoring system for better analysis? How do we convince them that it's for their own good, for the good of the occupants' comfort, for their monetary budgets? You know, like, how do we get them to see this? What's the simplest and best monitoring systems? Like, I don't know that either. And then what's the optimum level of refrigerant line insulation? And I ask you that because in our recent passive house project that I've been evaluating the temperatures on in a very painstaking manual way, the hallways and common areas are all overheating, and the hallways in particular, and I think that's because the refrigerant lines run down them and the domestic hot water recirc lines run down them. I don't know which is the blame, but they're like 8, 9, 10 degrees over their set points, and the apartments are not. So it has something to do with the line sets that are running down the center. So moving forward, this is what I mean. We always want to continue collaboration with the VRF manufacturers to find solutions for comfort and efficiency. We need to increase our education of our operation maintenance staff and our tenants so that they know how to react in their apartments and what to expect. We are working on real-time education at the touch of a button. So like, here's your building, you have an app, you click on cooling, you click on ERVs, and it tells you exactly what it is in your building that you have and how to maintain it and what to troubleshoot. So we're really working on that. Keep pushing everybody for monitoring, simple, you know, but comprehensive, simple yet something that tells us something. And then continued outreach to you guys, because I'm sure some of you have some great ideas for me right now. And then honestly, not to bag VRF manufacturers, but continued review of alternate solutions. FIA's had this great presentation the other day on heat pumps that are coming, you know, individual solutions and things like that, and retrofit solutions. We got an overview of that today from one of my staff, and it looks fantastic what's out there in research and development. So the PTHP is a packaged terminal heat pump unit that's cold climate, and then low temperature hydronic, which can be hooked up to heat pumps as well, is a very viable option for heating and cooling. The last thing I want to say is that for future considerations, we really should be considering, even though we have a champion for climate change in the White House right now, we know we're headed down this road of heat waves and hotter temperatures, so we got to keep that in account. Winter performance, we still must be able to meet the cold snap days, but handle part load efficiency. And then efficient low carbon technologies must perform in all climates and weather conditions. So that's the thing we're looking for. So that is my spiel to you guys. That's the end of my presentation. I'm going to stop sharing my screen, and I welcome comments, suggestions, solutions, but that's what works for me. So, and I want to say, I just want to reiterate, please don't throw out VRF. It really just takes some patience and some troubleshooting. The last one we just did, 200 Tyler, which is a historic retrofit, does not have as good windows in it because it's historic as a normal passive house project. And it just had some funky temperature set points in, say, like a stairwell that wasn't insulated versus the apartment. Once we got those under control, everything calmed down in the building. All the apartments are like within 1-2 degree of their set points, except for maybe 3 or 4. And I need to look further into why those are outside their set points. But we had a little bit of an uproar when people moved in about being uncomfortable, but it's completely settled down now.